In this video, we're looking at cylinders and we're going to be calculating surface area. So remember, that's the total area of the faces of the solid. So a cylinder has two faces that are circles, and then this curved face here that wraps around it, that is a rectangle. So if I draw that out, we've got these faces here, plus we'll have this rectangular face. So the length is the length that is given to us on the diagram. And then the width is something that we will need to work out. Now, if you imagine this rectangle is wrapping around the circles, that means the width of the rectangle will need to be this distance here. So this length would be the circumference of the circle. So we'll need to remember the formula for the circumference of a circle, which is going to be pi times the diameter, or 2 pi times the radius. Depends if you're given the radius or the diameter of the circle, which one is easier to use. And we will also need to use the formula for the area of a circle. So remember, that's area equals pi r squared, which is pi times the radius squared. In this example, we are asked to calculate the external surface area of this half cylinder. What that means is that we want the area of all of the surfaces on the outside of this shape. So we will have a semicircle at this end, the same semicircle at this end, and then we'll have this rectangle that curves around and forms the curved surface underneath the shape. So let's start by looking at the semicircular ends. So here I've just drawn out the semicircles that form part of the external surface of this shape. So each one of these semicircles has a diameter of 10, which means that they have a radius of 5 centimeters. And remember, to find the area of a circle, we would use this formula here, area equals pi r squared. Now, for a semicircle, I could find pi r squared for the whole circle and then divide by 2. Or I can use the fact that these two semicircles are the same size as each other, so I can put them together to make one whole circle, and then find the area of that circle. So now I'm finding the area of a circle with a radius of 5 centimeters, so I just need to do pi times 5 squared. 5 squared is 5 times 5, so that gives me 25 pi. Okay, so that's the area of my semicircular ends put together. So now I need to work out the area of this rectangular face. So the rectangle will have a length equal to this length here, which is 25 centimeters, and the width of the rectangle will be equal to this length here, which is half of the circumference of the full circle. So the circumference of a circle is given by pi times the diameter, and then because we have a semicircle, we will need to divide that by 2. So the area of this rectangle is going to be 25 times pi d divided by 2. Now we know the diameter is 10 centimeters, so I'm going to substitute that for d, and I'm going to get 25 times pi times 10 divided by 2. So 10 divided by 2 is going to be 5. So I've got 25 times 5, which is 125, times pi. So the final thing we need to do is we need to add together the different parts of the surface area. So we've got the semicircular part added to the rectangular part, giving us a total surface area of 150 pi centimeters squared. So let's try another example. This time we're calculating the surface area of this shape, which we're told is a quarter cylinder, and we're assuming the shape is solid, so that means that we're going to need to calculate every surface. So we have this end here, which is a quarter of a circle, the same quarter circle back here at the back of the shape, then we have this curved surface, and then we will have over here a rectangle, and in the base another rectangle. So we'll start with the quarter circles. Each one is the same size and has a radius of 12 centimeters. If we can imagine putting them together, they will make the area of half of a circle with a radius of 12 centimeters. Then we can use the formula area equals pi r squared, and then we can divide that by 2 to find the area of this semicircle. So the area here is going to be pi times 12 squared divided by 2, which gives me 72 pi. So now that we've worked out the area of these faces, let's do the next one, which is going to be this curved rectangular face. So the rectangle will have a length of 30 centimeters and a width of this length here, which is a quarter of the circumference of this whole circle. So the circumference is pi times the diameter, and a quarter of that will be pi d divided by 4. So the area of this rectangle is going to be 30 times pi d over 4. The diameter of the circle will be twice the radius, so that will be 12 times 2, which is 24 centimeters. So I've got 30 times pi times 24 divided by 4, and that gives me an answer of 180 pi. Okay, because 24 divided by 4 is 6, and then 6 times 30 is 180. Now, this is quite a complex example, so that's why it's really important to split it into small steps. So first working out the quarter circles, then we've got this curved rectangle. Now the difficult calculations are done. We just need to add on the area of the rectangle at the base and the area of this rectangle over here on the left. So in this rectangle, we need to do the length times the width. So this length will be 12 centimeters as it's a radius of the quarter circle, and then the width is 30. For the rectangle on the base, we've got 12 times 30 again. So that's going to be equal to 720. So now that we've calculated all the areas that we need, we just need to add them together. So the total surface area is going to be 72 pi plus 180 pi plus 720. On the calculator, that's going to give me this number. And finally, if I round that to 2 decimal places, I've got 1,511. And then after the decimal point, I want 2 digits, 6, 8, and the next digit tells me I'm not going to round up, so it's going to be 0.68 centimeters squared.
If you enjoyed this video, make sure you give it a like, and if you have any questions, leave a comment below. Subscribe to our channel to check out more of Century's content, and visit our website to find out about our learning platform.